gonna discuss all of O levels in IGCSE chemistry, ATP important stuff in just 15 minutes. Firstly, the things that you should know is the common laboratory apparatus that we use in laboratory and the purpose. First is measuring cylinder. We use it to measure different volumes of a liquid. Second is a crucible. You should know the shape, how does it look. You should be able to identify each apparatus. It's used to heat things such as mixtures. Third one is a beaker to measure approximate volumes. The word approximate is very important over here. Beakers are not used for exactly fixed precise volume, it's for approximate ones. Evaporating dish used to evaporate things. You should know all of this. Flat bottom flask to hold liquids. It's fine if you just round it and then call it a round bottom flask, or you make it a cone shape and then call it a conical flask. The name of the flask can change. Dropper, it's used to transfer the small volumes. Then conical flask, cone shape, tongs or test tube holders, they're going to be used to hold test tubes. This is a round bottom flask because it's round. Then you have a test tube, it's used to contain small liquids. Filter funnel, again a very important apparatus that is often tested. It's used to basically used in filtration to separate the solids. Then you have tongs, they're used to hold things that are heated. Then you have a burette. Burette is very important, used to transfer acid or alkali during your titration thing. Test tube rack, not that important. Bunsen burner, again you should be able to label it. Glass rod, it's used for mixing things. Wash bottle, used to transfer distilled water, or like if there is something that you need to transfer in like not fixed volumes, just like randomly, then you can use wash bottle. Then there's a pipette filler. Pipette filler is important because it's used to fill pipettes, right? Then you have a watch glass. You can put stuff in here to hold things, but not that important. Again, stand, not that important. Gauze is important to support the apparatus when heating, to spread heat when heating a flask or containing. That's important because you know that when you heat from a Bunsen burner and you have a beaker over here, for instance, you need to spread the heat to the entire base of the beaker, because if only this place gets heat, it will be heated a lot, right? We want it to spread entirely. That's why we use this thing. And then you have a tripod stand. Done with the apparatus. A few more. Thermometer, used to measure the temperature, important in heat related experiments. And pipettes, again, they're used to measure very precise volumes like 25 or 50, and they come in fixed volumes. Next thing, we're going to discuss some important questions that the examiner tests a lot and you guys should have a little knowledge about them. How to add a salt to an acid in a basic acid plus insoluble base reaction. How do you add salts? You use a spatula. Why is heat not required sometimes in an acid plus insoluble base reaction? Why don't you need to heat it? Because reaction is fast enough at room temperature, you don't need to heat it. Define in excess. Excess means unreacted, still solid, and insoluble. Okay? Something that is not reacting, that's not taking part in reaction. Okay, after the reaction is finished, it's still left there. How to form crystals from an aqueous salt solution. How do you form crystals? You should know the process of crystallization. You filter out the unreacted excess, the part that's unreacted, you just throw it out. You heat the remaining thing till crystallization point. It's very important, till this solution is saturated, and then you check it with a glass rod. After you have checked it with a glass rod, then you allow it to cool and crystallize, and then your crystals form. Okay, errors in titration process. When you do titration, there can be errors in it. Using a measuring cylinder to measure the solution, this is a very big error. Why this is an error? And this is a very common error because you don't use measuring cylinder. Why? Because measuring cylinder gives you approximate values, and for titration you need exact values. That's why you should use a pipette. That's an error. Only carrying out experiment 1, that's an error. You should do it at least 3-4 times. Okay, going past the endpoint, that's a very big error, because when you're adding something from the burette, you are so casual that you just open it out and then you pass the endpoint. How to avoid the errors? It's very important to know the errors and then how to improve them. Repeat the experiment. Good. Improvement linked to going past the endpoint, to be vigilant in resistor changes. Okay, changes in apparatus. Use the pipette, very important. Use insulation lid so that heat is not lost during your titration, but it's not that important. As more accurate, precise than a measuring stand. Okay, reduce heat losses, polystyrene cup, but not very important in titration. This is more important in the heat experiment. How do you do flame test? Flame test, again, very important. important thing for flame test is you use a blue roaring Bunsen burner flame. Flame test cannot be done on yellow flames. It has to be done on a blue flame. Then how do you perform it? You take a splint wire, introduce into the solid or the liquid or whatever. You take a wire, put it in that thing, then take out the wire. Don't write do this thing. You take out the wire, put it on a blue Bunsen burner flame, and you get the flame color. Okay, take a wire, put it in the solid or the liquid, and then put that wire on the flame. You're gonna get your test. That blue, yellow, green flames you're gonna get. What is necessary to gently heat the solid in the test tube first? Okay, it's important that when we are doing heat experiments with the crucible, okay, with the crucible we are doing the heat experiment. Why is it important to heat it gently first? We heat it gently so that the solid does not spit out of the tube. It's very important, very important. People think that it's just random that we're heating it gently in the beginning. No, it's not random. We're doing it because we don't want the solid to spit out. Okay, define solubility. It's the maximum amount of solute dissolved in a solvent at a given temperature. That's the solubility. Because if you increase the temperature, then obviously more solute will dissolve. Why? Because when you increase the temperature, you increase the spaces between the water molecules. So now more solute can dissolve in it. Okay, obtaining pure water from a mixture. How do you obtain it? You heat and boil the mixture, and then you do distillation. You condense the vapor. That's how you're going to obtain pure water from a solution. Distillation. Obtaining sand from a mixture, filtration. Filter or decantation. What is decantation? People don't get decantation. Very easy. What do you take? For instance, if I have this black solid over here and I need to remove this from my mixture, and I have this. What is going to be decantation? Because the solid is so big, if I simply pour off my mixture into another beaker, the solid is going to be left behind. So that's simply decantation. You don't need a filter paper for decantation. It just happens that you pour off the liquid and the solid just remains behind. You pour it off slowly, like very slowly you're going to pour it off. The solid is not going to be going with it. Okay, clean with water and then dry the sand. Good. Colors of solids are very important. You should know white solid and forms colorless solution. These are all white solids. Potassium solutions, they're going to be white in color. Potassium bromide, potassium chloride, potassium fluoride, all white. Potassium oxide, all white. Calcium, sodium, magnesium, aluminum, all group 1, group 2 salts, white in color. Zinc, barium, silver, lead, ammonium salts, all are going to be white in color. Please don't forget the colors. Pale green, iron 2+ ion is going to give a pale green. Then green, don't remember the nickel one, but remember the chromium one. Chromium is also going to give you a green one. Then yellow brown, iron 3+, blue is going to be copper 2+. Remember the colors and the colorless ones. Then this is a very important question. What is this thing? This thing is a delivery tube. Okay, you use delivery tube to transfer substances. What is the purpose of water above? So you can see over here that there is water over here and mixture of alcohols. You might be heating it and alcohols are evaporating, and they're asking why is there water over here. You should be able to deduce things from the experiments. That's very important. The first question always in an ATP paper is gonna ask you to deduce something from the experiment that's taking place. Your deduction skills should be very good. There can be ice over here as well, but right over here you have water to condense the vapors that are coming. Okay, reduction skills should be 100%. Condensed vapors form gaseous to liquid state. Again, very important that by seeing an experiment you can conclude things out on your own. Okay, what is the thermometer bulb placed as shown and not in the mixture of alcohols? Again, why is the thermometer placed here, not in the mixture? Because look, what's the purpose of the thermometer? It's to measure the temperature of the vapors. If it's inside, it's going to measure the temperature of the alcohol. We don't need the temperature of the alcohol. We need of the vapors that are going to come from here. So that's the point, okay? To measure the temperature of the vapor of the liquid would not be constant. We know that the temperature of the alcohol would increase, but the vapors, they're only formed at fixed temperatures, because when a substance changes from solid to liquid or liquid to gas, whenever state change occurs, what happens? The temperature line becomes flat. The temperature of the substance does not increase, because all the energy supplied is used to change the state and not the temperature. Okay, given advantage or disadvantage of using a measuring cylinder. Measuring cylinders we use because they're quick but they're not accurate. Okay, ways to improve a reaction. Okay, firstly we're going to use burette or pipette because they're more accurate. Then gas wrench to collect gas. We are not going to use that displacement by water. There's a method, displacement by water, in which you displace water. Why we won't use it? Because in that method some of the gas might dissolve in the water, but in gas wrench it's accurate. Weighted amount of limiting reactant, okay, that's good. Repeat experiment and average clean reactant, remove oxide layer. Okay, methods might be helpful. What is a solid substance has no obvious cation? We have learned it's probably a transition metal compound, is a catalyst for other reactions that occur. When a solid substance has no obvious cation, not very important. Okay. Then again, that's the metal reduction reactions, that when you have to obtain one metal from the oxide of that element, what do? You make it react with carbon. If the carbon is more reactive than that metal, it is going to displace it. You should know it. How would the results be improved? By taking repeated measurements. If you repeat the experiment, you can take average or mean. You can spot the anomalies. Anomalies mean something that's an abnormal result, and it becomes more reliable. Important. Name a suitable indicator that could be used in titration. Methyl orange, thymophthalein, litmus, all indicators good. Okay. Then again, we have an experiment. Describe test for carbon dioxide. You know, it's written in the notes as well. Suggest how the reliability of the experiment could be checked. Repeating experiment and comparing and taking average, that's going to make it more reliable. Experiment. Okay. Suggest one advantage of putting a layer of chromium on a spoon. Prevent rusting, corrosion. Why must the electrolyzing object be very clean and free of grease? Coating will not stick evenly. Very good. Because when you're electrolyzing something, you need it to be very clean. Okay. Why was the burette washed with distilled water? That is very important. We always wash burette with distilled water. Why? To remove the impurities. And then we wash the burette with the substance that is added in the burette. Why? So that the concentration of the substance does not change. Because look, if you just wash the burette with distilled water, there is going to be some water particles left. And if there are water particles and then you add your substance in the burette, for example, the substance is yellow in color, what's going to happen? If there are water particles left in your burette and then you add the mixture, this yellow thing is going to get diluted because of the water over here. So it's important that you wash the burette with water and then you wash the burette with the yellow thing and then you add the yellow thing in it. Okay, so this should be washed with the yellow thing, so there are only yellow droplets here, so that the concentration of the thing in the burette does not change, it does not get dilute. That's important. Okay, if the composition of salt is not clear, just mention general observations like hydrated acidic bases. Copper sulfate plus water, it's gonna get from your white to blue. Cobalt chloride, initially it's gonna be blue in color. You add water to it, it's gonna get pink. Okay. Types of indicator we know. Okay. Explain why cotton wool was used to at the neck of the conical flask. Very important. Rate reaction. Always a cotton wool over here, and they ask you why. Why do you put this cotton wool over here? Gas. Okay, you're making a gas over here, and gas is gonna escape from the cotton wool, right? It's gonna escape. But then why are you putting it? To prevent the escape of the acid. We don't want the acid to splash, to allow carbon gas to escape slowly. We don't want all the gas to escape at once. There might be a blast or something like that. We want it to release slowly, and then we want to prevent the escape of the acid. Okay. You're provided with the samples of 3 metals, zinc, copper. Plan investigation in order for the reactivity of this metal. You know how to determine reactivity. One is going to replace the other. That's all. You can read it. We know this. Inert electrodes, platinum, graphite, gold, rhodium, don't learn, just graphite and platinum important. Reactive electrodes, copper is important, and then silver for silver plating. Explain why electrolysis of concentrated HCl is carried out in a fume cupboard. Because when you're going to do with concentrated HCl, you're going to produce chlorine, and chlorine is toxic. Important. What type of chemical reaction occurred when magnesium exothermic? Redox, displacement. How can it be a redox reaction? Because magnesium and hydrogen changing oxidation states. You can check it. And displacement, because magnesium is displacing hydrogen from HCl. Not HCl, from sulfuric acid, the hydrogen. It's forming magnesium sulfate. Uh, Oxidizing agent, reducing agents, okay, done. Test for ammonia, no problem. How do you know when to stop heating a solution in an evaporating dish? Solid starts to appearing, and the glass rod test. You put a glass rod inside it, then you take out the glass rod, you see if crystals appear on the glass rod, you know now you need to stop heating because the solution is saturated, okay? If there's no change when testing something, no reaction, no change, you write good. Commonly, you may diagram help you. Okay, for chromatography, you should know the things. It's easy. Always remember. One thing, always remember. If you're going to get an experiment in which you have leaves, or you have beetroot, or you have a fruit, or you have a vegetable, if you anything, and you're doing chromatography to it, you need to crush it first. You need to extract it, you need to crush it using a pestle and a mortar. Very important. Without crushing, you're not gonna get the extract, the liquid part that you're gonna put on your chromatography paper. Okay? You cannot put an entire leaf on the chromatography paper. You need the liquid out of it. That's important. And that's all the important stuff I wanted to tell you guys.